All right, so here's another example for adding these rational expressions. Now, my denominators were both monomials. So I first need to figure out what is my least common multiple. Now I told you before when we did this that you do not need to write out the factorization of all of the monomials. But first thing I'm going to look at is I'm going to look at, well, what is the least common multiple of my coefficients? So 1 and 2, the least common multiple is 2. Then I know each of my variables has to be in my least common multiple. So I have an x, so x has to go there, and I use the highest exponent, which in this case would have been the 3 right there. I have a y, so the y has to go there, even if it's not in one of them. And the highest exponent there is 2. So I know my goal now is to get to a denominator of 2x cubed y squared, 2x cubed y squared. So now I just have to start this process of saying, well, what am I missing? What do I have to multiply by? So to get from a 1 to a 2, I know I have to multiply by 2. I have y squareds, so I'm good there. And then I have x here, but in my LCM I have x cubed, which means I'm missing on x squared. So I need to multiply my numerator and denominator by 2x squared, which gets me 2x squared. So I'm going to do the same thing here. Well, I have 2x cubed in both of them, but this has y squared, so I would need to multiply by y and by y, which gets me to 3y. Nothing is simplifying here. Now I need to combine or simplify my numerators. So when I do that, I'm just left with 2x squared plus 3y, and then I want a single denominator, which works out great because I have my common denominator. So my common denominator is the 2x cubed y squared. Now, if I take a look at my numerator right now, nothing is going to factor out. If nothing is going to factor out, I assure you nothing is going to cancel. So this is your answer. Okay, now this is the last one that we are going to do together, and then you'll get time to work. So here now, this one is different because now I have a problem that is going to involve subtraction. Now, this might not seem like a big deal, but subtraction problems are the ones where I see the most errors take place. So there's going to be a few ways that we can kind of talk about how we are going to prevent these errors from happening. But the first thing we have to do is we have to find our LCM. So in order to find our LCM, we factor those denominators. And there's no reason to factor your numerators if you ever have one that's factorable. Okay, so for my LCM, I can see that I have an x plus 3 that is shared, so that will go in one time. And then my leftover factors are x minus 3 and x plus 5. So my LCM for both of those and I like to write it like this because it gives me my goal. It gives me where am I going. So now I start to kind of play the what's missing game. Well, x plus 3 times x minus 3 to this LCM. Well, obviously that x plus 5 is missing. So I would need to multiply my numerator and denominator by the x plus 5. Well, we've kind of already done it for the denominator. I already have my LCM. But in my numerator now, I have 2 times x plus 5. Now, when I compare these, now I'm missing this x minus 3. So that means that I would have to multiply my numerator and denominator by x minus 3. Now, what I need to kind of be very careful with and point out here is that this minus is here. And so when I would go to distribute that and I would get 5x minus 15, I would then have to remember that I'm subtracting each of those terms. And typically people don't remember that. So one of the things that we can do is, instead of looking at this as a minus, I can look at it as adding the opposite. So when I go to simplify my numerator, I have negative 5x plus 15. And over here I have 2x plus 10. So now all I have to do here is look at those two numerators and combine my like terms. So when I combine my like terms, I'm left with negative 3x plus 25 all over the common denominator. So oftentimes if you're having to add the opposite, it's going to become really helpful to you as to not make this common error that people do make because they forget they're subtracting both terms here. So our final answer, right there. Nothing factors, so nothing cancels.